Welcome back, everybody. Part-time adjunct here. I just want to take this opportunity to finalize the abstract classes versus interfaces topics, because I know we covered abstract classes previously, and then we also covered interfaces. And you're probably wondering, well, when should I use an abstract class versus an interface? So again, this is going to be a short video because the answer is really short, at least in my opinion. So with abstract classes, if you know that there's going to be no change, then you should create an abstract class, define some methods, and then leave some methods to be implemented later. I think this is a good rule of thumb, because once you define a method in an abstract class and you make a concrete method inside an abstract class, if you ever need to go back and change it, then every single class below it is going to be obviously affected, right? So your best bet is that if you know that you're going to build an application and you want to create some base classes which are abstract, and they're a combination of defined and undefined methods, make sure that the defined methods are not going to change, meaning that the implementation is not going to change for those defined methods, because then you can get into a lot of trouble if you need to go back and tweak some of them as you go. With an interface, for me at least, is more flexible, because even though you do have contracts, you can always add methods to the interface, and this will affect your child classes. Yes, it will, but not in a way where an abstract class will, because all you would have to do is just implement that method, but you can leave it blank or just throw a not implemented exception. So if you need to add methods to an interface or contracts in an interface, it's a lot more flexible in that case, right? And then you also have individual classes that are implementing your interface. And if, let's say, you have C1 implement the same interface, right? So let's do an example here. So C3, right? So actually, this is bad. This is not good. So I'm actually going to do a new drawing here. So suppose you have an interface. Just call it I something. And then you have class 1, class 2, class 3. They implement that, right? C1, C2, C3 will have its own implementation of whatever method they need to implement from the interface. This implementation and this implementation and this implementation will be different in terms of logic, and that's perfectly fine, right? Now, if I need to add a method inside interface, so let's say we have, send and then receive, right? You most likely will not want to add another method inside the interface. What you want to do is you want to create a new interface, just call it I2, right? And then create your method in here. So let's just do double send, right? The reason for that is you don't want these things to change here, okay? So what you can do is, because you can implement more than one interface, right? Then I can pick and choose who can implement I2. So if I said, okay, I only need C3 really to implement I2. So C3 can implement I and I2. We'll just call it I1. I1 and I2, these stay the same. You don't need to change any code. When you have an abstract class, it's different, because you don't implement an abstract class. You actually inherit from it, which means that if something changes in your abstract class, then the inheritance may or may not break. okay? And especially if you need to add some abstract methods, then anything that inherits your abstract class is going to have to change, right? So I'll give you an example. So let's say we have A1, right? The children of A1, let's do B1, and then we'll do C1, and then D1. Remember, there's an inheritance chain with abstract classes, right? You don't implement an abstract class. So let's say you have receive, end, send, right? You can't take the approach that we took here because you can't have multiple inheritance. So if B1 inherits from A1 and you wanted to create A2, right? And A2 had a double send method, you can't inherit from both. This is no good because you don't have multiple inheritance in Java. Which means that you're going to have to add the method, this double send method in here, right? And get rid of that. What does that mean? Now, if you're safe if it's a concrete implementation, but most of the time it's not because B1, C1, D1 would probably want their own implementation of double send. And if that's the case, then now you're messed up because B1, C1, and D1 are going to have to define double send, and anything that inherits underneath will also have to redefine it. So I would advise against using too many abstract classes in your application because that means that your application is not going to change, and that's not really fact, right? Applications constantly evolve. That's why my preferred approach is to use interfaces. Now, the abstract classes, yes, there is a need for them, and you can use them at least for data objects that perhaps you're going to be sharing across an application. That's when I really would use an abstract class with different properties. So again, one example is if you're looking at let's say you have I'll give you another example here. So let me just go up here. So here's an abstract class example of when I would use it. So let's do an abstract class, right? So let's say you have an abstract class. We call this, let's call it the DB class, right? So DB. So your DB class is going to have certain properties from the database. So maybe you have first name, last name, and maybe the ID, right? If these properties are coming directly from the database, right, as a person, right, let's say this is a person object, right, so the person object is going to map to a DB table called the person table, right, so you basically it's just a kind of an entity what we call an entity object, right. I can make person abstract, and then anything that inherits from person can just add on to these fields. So let's say I have a student person, right? Student person will include these names, and then let's say I want to have additional fields that I maybe want to validate. So maybe I'll have, GPA. I'll have credits. Okay, so this student person class will inherit from my abstract class person, right? And any type of extension for person, because it could be a student person, I could also have faculty person, right? Will always inherit from person because I know that these things are not going to change because they are bounded to the table in a database. So let's say you have a table here. And then you have a person table, and the person table has these fields, right? So first name, last name, and ID, right? This is not going to change because if you change this, then you're going to have to change your table structure, and you're not going to do that, right? So that's when I would actually take the abstract class approach because I know that it's not going to change. What I know it's going to change are the inheritors. So a student person may have GPA and credits. A faculty person may just have, faculty load or credit load, right? And then they can have their own properties inside each class, right? So student person would be a class, faculty person. Both of them inherit from person, and I know that these fields are not going to change, so I would make that an abstract class. Simple example. There's others, but if you want me to give you other examples, I can give them to you if you send me a comment. Okay, but so basically that is where I stand with interfaces versus abstract classes, or abstract class versus interface. So simple rule: if you know that there's not going to be no change in terms of the application or whatever you're trying to abstract, then I would use abstract class. If you know that's going to be plenty of change, then I would use interfaces, because with interfaces you don't have to, although there is a lot of change, right, you can keep your code intact and not change the implementers, right, as we saw in this example here. Okay, so I hope you enjoyed that. Just my take on it in terms of architecture and architecting code. I hope that you learned a little bit. Again, these are very simple examples. If you want more complex examples, you can always reach out to me. I can kind of give you my take on what you're trying to build. So I'll see you on the next video.